Hello, my dear students, and welcome to my YouTube channel. My name is Dr. Vandana, and this is the second lecture on the topic of matrices. In the first lecture, we had discussed some important types of matrices, and to learn about some more advanced types of matrices, it is essential for us to understand the algebra of matrices. By algebra of matrices, we mean how to add two matrices, how to subtract, what will be the multiplication of two matrices, and what is the scalar multiplication. So let us discuss all these operations one by one. So the very first operation on matrices is addition of matrices. So if we are given two matrices A and B, so addition of matrices can be done if and only if they are of the same order. And how you will add the two matrices? You will just add the corresponding elements of A and B. For example, if this is the given matrix A, this is the given matrix B, then for adding A and B matrix, you will simply add the A11 and B11 elements. So that will be 1 plus 2. That makes it 3. Then you will add A12 and B12. 3 plus 1. Similarly, minus 2 plus 0. 5 plus minus 1. 0 plus 3. And 4 plus 2. This will give you the addition matrix as 3, 4, minus 2, 4, 3, 6. So this is your addition of matrices A and B. Now, one thing you have to keep in mind, whether you add A plus B or you add B plus A, the answer will remain same. That is, matrix addition is commutative, means the order of addition will not matter here. Second operation is defined as subtraction of matrices. So this is very similar to the addition of matrices. If you are given A and B as the two matrices, then obviously the order of the matrix should be same. A minus B will be obtained by subtracting the corresponding elements of B from A. For example, these are your two matrices. If you are finding A minus B, then you will subtract the elements of B from A. That will be 1 minus 2, 3 minus 1, minus 2 minus 0, 5 minus minus 1, that will be plus. So this is your corresponding subtraction of matrices. Now, one thing you will keep in mind, that subtraction of two matrices is not commutative. Not commutative means if you are finding A minus B and you are finding B minus A, the results will not be same. So hence it is non-commutative operation. The next operation is matrix multiplication. So if we are given two matrices A and B, and order of A is m cross n, order of B is n cross p, then we can find the product AB of order m cross p. Now, what is the condition for existence of matrix multiplication? So your product AB will exist if the number of columns in A is equal to the number of rows in B. This is the mandatory condition for finding the product AB. That means number of columns in the first matrix should always be equal to the number of rows in the second matrix. For example, if we are having this matrix A, this is the second matrix B. What is the order of A? 3 cross 2. What is the order of B? 2 cross 3. Is number of columns in A equal to the number of rows in B? Yes, it is same. So we will say that the matrix multiplication AB is existing. And how we will find the product AB from these two matrices? So what we will do? For writing the first row in the product AB, we will consider the first row of A and multiply it with the corresponding columns in the matrix B. That means if I need the first element, I will multiply first row with the first column. That means 1 into 1 plus 4 into 2. This will be my first element. If I need the second element, I will multiply first row with the second column. That is 1 into 3 plus 4 into 0. If I need the third element, it will be first row multiplied with the third column. 1 into 7 plus 4 into 5. Likewise, if I need the third row in the product, I will multiply third row with the corresponding columns of the matrix B. That means 3 into 1 plus 6 into 2 will give me the first element. If I need the second element in the third row, it will be third row multiplied with the second column. That means 3 into 3 plus 6 into 0. Likewise, 3 into 7 plus 6 into 5 will give me the last entry, that is A33 of the product AB. And when we simplify these values, this will be my product AB. And as I have already mentioned, the product AB will exist if and only if the number of columns in A is equal to the number of rows in B. This is the mandatory condition. You cannot skip this. If this condition is not satisfying, you will say that the matrix multiplication is not possible. Now, one more thing which is important, that matrix multiplication is not commutative. Means whether you find the product AB and you find the product BA, it may or may not be same. And one interesting fact is that if the product AB is existing, it may happen that the product BA is not even existing. And even if it is existing, the results may differ from each other. That is, matrix multiplication is not commutative. And the last operation is scalar multiplication. Scalar multiplication is basically the operation of multiplying each element of the matrix by a scalar k. Suppose we are given this matrix A and k is any given scalar, then we can find the scalar multiplication ka by multiplying each element of the matrix by this scalar k. For example, if this is the given matrix A and we are trying to find 2a, then we will multiply 2 with every element inside the matrix. That means 2 into 3, 2 into minus 1, 2 into 4, 2 into 2. This will give me my scalar multiplication twice of A. Right? Now this scalar can be 0 also, can be non-zero also, it can be complex value also, it can be a fraction also. There is no restriction on this scalar k. If you take k as 0, so it will be 0 into A, that will be a zero matrix. This will be the zero matrix. So I hope that you have understood all the 4 basic operations of matrices clearly. If you have understood these operations properly, then please answer this question in the comment box, that if these are the 2 matrices, you have to find these values. And if you feel that this video has been helpful to you, then please like this video, share this video, and please do subscribe my YouTube channel for the upcoming next videos. Thank you.